So professional. We're live? We're live? Okay, awesome. All right, so thanks everyone for joining. I'm Victor. Actually, this is the first time I'm on any hacker event, so I'm already sorry if it's like not technical enough or too technical, whatever. I call it over-engineering a smart doorbell. It might just be building one for you, I don't know. But maybe, hopefully, you learn something. Hopefully, yeah, I can show you some cool stuff. So first of all, who am I? I'm actually a commercial engineer, which is like a corporate shill, right? But then I started to go deeper and deeper into the programming rabbit hole, and now I really, really like it. So now I work as an ML engineer, you know, like the script kiddies that do all of the deep learning stuff. I'm not too good at it yet, but I like to tinker, right? So just like all of you, that's one of the most fun things to do, which is also why I built like the doorbell detector. So maybe about the over-engineering thing. So it's just the fact that I think every one of you lives and breathes this here. But it's just really nice about thinking, okay, how can I solve this thing? Like I have an issue with my doorbell, and you can like buy something, but no one here will. You can also like over-engineer the crap out of it and like build a whole retraining pipeline with machine learning and everything else, which is what I'm going to talk about today, right? So I hope you enjoy this. It's may or may not be over-engineering, but it might be interesting. So first, some context, right? I'm talking about a smart doorbell. So like every one of you probably, I've been working a lot from home during COVID, obviously. And so the idea there was that if this is my house, I'm all the way upstairs. I have like the nice attic, you know, where everything is. Looks a bit like the hackerspace, actually. And then packages arrive down below, and they ring the doorbell, but obviously I can't hear it. I'm also working like with the headphones and everything. So we need like some kind of way to get me to know that there is someone at the door, right? And that's the whole of it. So it's basically just, I wanna know when someone rings the doorbell. That's all there is to it. All right, so then we are like at the moment that we can start building a plan, right? So you have this idea, you think, okay, I'm gonna make this awesome, this is gonna stay and work and do everything that I wanted to do. Obviously it's not gonna be, but yeah, you're always happy in the beginning. So option one is obviously to sell my soul, and actually it's cheaper, more expensive than I thought. Like if you buy a Ring doorbell, it's like 80 bucks, and actually that was on sale. So you do get a camera with it, you don't get one with mine. It's something, but we all know what is going to happen here. We're not going to do that. We're not going to sell ourselves to the corporate shills. So we have some options, right? So at the left for you, there's my doorbell, right? I put the thing off. You could say, okay, like I'm just going to plug hotwire like an Arduino or like an ESP32 into it, and then the moment that it gets like a signal, then it starts up and it basically screams like there's a bell on Bluetooth or on Wi-Fi, and then some Raspberry Pi base station can pick it up, right? That would be a nice idea, but you need like obviously an AC to DC converter. I'm not gonna put the Raspberry Pi, not gonna put the ESP32 on like the main net. That's probably a good idea. So there is the risk of death. In my case, I'm very inexperienced with this stuff, so this will kill me. I see this as a bad thing. Then there is also, like the code would be simple and easy to maintain, which obviously this is a hobby project, so that's also like a negative side. We don't want this. Then like the system would work reliably and with no false positives. It just gets like, power basically, which is obviously also something we do not want in a hobby project. So we throw all of this out and we go for the hard way. Also I posted this in chat on my work, and like this guy is always there. Pinging me off, so we're just going to ignore this for now. That's too good of an idea. So we're going to do the DIY option, obviously. So what I thought of was like, okay, I'm an ML engineer. Let's maybe like use this knowledge for at least something. And so let's just wire a simple mic to a Raspberry Pi. Could be just a webcam or whatever. And actually, the shittier the mic, the better in this case, because like noise from a doorbell is basically background noise. Better microphones filter that out. You don't want that. So you want like the cheapest, shittiest mic you can get. And you basically hook it up to Raspberry Pi, and then we use some ML magic to get it to recognize the bell, right? That would be the idea. All right, so we decided to go this route, right? We decided to go the hard way, or like hard way. We now have to do some data preparation. So you put the Raspberry Pi somewhere, like hook up the audio, like the mic, right? And you start gathering data. That's the main idea. You just need some examples of like the bell ringing, and you need a lot of examples of the bell not ringing. It's simple as that, right? So you get something like this, which is just some data. This is like a second and a bit of noise that is actually the sound of my bell, right? So at this point, you take this block of data and you're just gonna say, I'm going to cut it up into pieces because the bitch that a machine learning is, she doesn't want like different sizes, right? So you need like every single bit of data to be the same size. So we take about like the smallest length that was a doorbell sound, which was about half a second. So we take half-second windows out of this, right? Which leaves us with, like, this is basically the first part, this is the second part, speaks for itself, right? So you have now, like, two pieces of audio that contain what can be reasonably called a bell, right? And that actually gives us a nice overview. So on the left, those are, like, samples of, yes?
Did you also try to throw in, like, background noise?
Yes. So on the left, you see like all of the bell noises, and I also like shouted in between and like stuff like this. But usually, like in the use case that I was working on, I would be upstairs and nobody would be home because otherwise, yeah, my girlfriend would just open the door. So it would, yeah, you don't need that much like randomness. But on the right, yeah, I vacuum cleaned, I shouted, I cooked, whatever, for like an hour, and then just got all of the not silent audio out, right? And that's all on the right. But it's really nice to see, like, it's not that clear on left versus right, so you might need like a deep learning system, maybe. Could be nice, could be not. So then, machine learning. So that's the approach which I chose, right? So like any good hobbyist, right, you start basic, you build your way up, so we dive straight into deep learning. That's the idea, right? Let's just take the most complex stuff we can do and build down from there. So to give you an idea, so deep learning, I first started with, like, I'm a computer vision engineer mainly at my work. So I was thinking of like using convolutions, right? Convolutions is this really cool thing. On the left, you have basically the image. So now I'm talking about images, not audio for a while, bear with me. So on the left, you have like an image, right? And every block is basically a pixel. Every value in it is the value of that pixel, right? It would be 3, red, green, blue, but let's just keep it simple for now. And then you have like a convolutional filter, which is the blue part. And that basically just goes over all of these things. And you have a filter itself. And then it's just simply, okay, saying I want 7 times 1, 4 times 1, 3 times 1. The middle row you can ignore because it's all times 0. And then on this side, you basically have -3, -3, -2, right? And if you do that sum, you basically end up at 6. And in this way, what the machine learning model basically does is it tries to learn this part. And then it can kind of get the most value or the most information from the left to the right, which leads it to less data, which is nice because we don't want to wait years for like a doorbell, right? So that's how a convolution basically works. This is computer vision, right? So, but some smart people came up with the idea, like, you can actually do computer vision on audio. So if you take like an audio, you take a very small clip of this, and then you're going to take that very small, so this is like a half-second window, right? You take like a smaller window out of this, you basically point it towards the side, and now you do a Fourier transform, which is a fancy mathematical thing that I would be stupid to say that I understand. But basically, you get like the different sine waves and cosine waves that compose the part of audio. You point it towards the other side, like you project it basically, and now you have the frequency domain. So now you know which frequencies are how loud in the part of audio that you have, right? And then if you look at the frequencies from the top and basically project it like this, the more yellow it is, the higher the wave was, right? And so basically the only thing you have to do is just take all of that and just smear it out. And now you have a spectrogram, right? So now this is an image, as far as I know. So now you can use convolutions, okay? So now you can actually, you've basically transformed audio into video, because why not? And then you can use basically deep learning for that, right? So how does it look like in code? Basically, you build a sequential model. It's very, very easy actually. So you add like convolutionals, so conv2D is basically 2D convolution. The kernel size is basically the size of the blue thing that you write over it. Then it's like max pooling, which basically says I'm going to take the maximum of this, just to get it even smaller, right? You basically want to get rid of useless data, that's the idea. Then some dropout, which is basically just saying I want to not use some layers sometimes, some neurons, sorry, sometimes to make it learn better, that's the idea. You flatten it, so yeah, from 2D to 1D, and then dense layers, which is basically just a normal neural network that everyone knows. All right, this is how it looks then, right? So you take basically the spectrogram of the whole thing, and you take windows out of that and do computer vision on it. Sounds nice, doesn't work. Too bad. So it was cool, it was really nice. I tried it, it does actually work, but it's like, meh, it's not very good. So we have to like swallow our tails, not deep learning, let's just keep it to learning then, like less deep learning, maybe. So what you can actually do, the convolution, if you remember correctly, it actually also works on 1D, right? So you don't actually have to like transfer the whole thing to an image, you can just do it straight on the audio signal, right? It actually works very much the same way. The computer learns this, you convolve it over that, and you get like less data and less data and less data until at the end you basically get, is it a bell or is it not a bell? That's the idea. So that's then like how that looks, right? So I took this picture from the internet, so it's not, basically what I want. So this should be audio, right? But you have still, like it's a time series, it's just a point value at a specific time. And then you basically convolve it in the feature maps, basically, and that's what a feature map is. It's just a convolution, the in-between steps. And then on the right, you have like the fully connected layer, which is just normal, deep learning. And then at the end, you have like this one block that says 0 or 1, bell or no bell, right? Doesn't work. At least doesn't work the same way as the other one didn't work, right? It's like 70% accuracy or something, but it's just a pain in the ass. If you have this running the whole time, your cell phone is basically just being spammed with like images, like there's someone at the door, there's someone at the door. So we're in too deep, right? We're in too deep. We need just some crying first, right? We have put a lot of time into this. It's not working. Several weekends later, we have the knowledge now, and actually I should know this because I'm an ML engineer, but still, deep learning models need a lot of data. I didn't have that much data, especially like the computer vision you can use like transfer learning, which is basically using knowledge from other sources also on yours. Can't do that with just normal like time series, right? So deep learning models need to learn the data from scratch, which is why they need so much data. And it takes quite some computation to train, and I wanted all of this to work like on a Raspberry Pi, and it like took forever, and then it freezes, and you know the drill, right? So step 4, we just keep it with learning, right? So the idea here is that humans actually have spent a lot of time analyzing sound. It's like a thing that we do. We know this, and we already know what is important, what the important bits from a sound wave are. So we don't actually have to use deep learning to get like the relevant parts out of noise. We already know what the relevant parts are, right? So why not just use that and like get relevant parts out in a better way, like they're called MFCCs. I'll go later into a bit more there, and then just use an SVM, which is just a normal statistical machine learning approach instead of deep learning to do the rest. And it's just very, very simple. It runs really quickly. And so the idea there is that this is a bit too difficult now, and also I don't understand it that well, so I can't really go into that much. But the idea is that you take the spectrogram that we had before, and you use basically DCT, which is discrete cosine transform. It's a lot of math, but the idea is that you get a few numbers out of it, and you use those numbers. That's the idea. But people have decided over like 50 years of research that the DCT is actually quite nice in getting the relevant parts out. There's also use for JPEGs, actually. There's a really good number file video online. So how do we do this? Like MFCCs, all of this that I just said, don't have to really care because there's libraries in Python that you can just do this with. So all up the top, you just create the MFCCs, which is the numbers that we basically need, that they've decided that is a good measure. And then you use grid search CV, which makes your life even easier by just saying, I will basically try everything that I have and just keep track of everything. And the best thing is the thing that I'll give you. That's what it's going to do. So it's going to search for everything, and it's going to give you the best result. And that's also the fitted model is then that best result, right? You get a model that's perfectly aligned to what you want to do. And then you just get some predictions back, either 0 or 1, or probabilities. I'm dead sure that it's a bell or not. Finally, that's really nice. Actually, full disclosure, it's still kind of shit, but it's not that bad anymore. So now I get like 1 false positive every week or something, which is fine. So then you just kind of swipe it away. But it actually saved my ass quite a few times so far. So it actually seems to be doing all right. Haven't really maintained it yet though. So deployment is how to keep this from becoming the 598th piece of trash in an endless heap of failed abandoned projects and misery. You all have this pile, I would assume. So the idea is here, I want to go one step further. I now have like this machine learning model that does cool stuff, but how can I actually get it to work, right? I need to do something with it. I need to maintain it because it has an actual function that I want it to do. Right, so large diagram, but I'll talk you a bit through it. So the idea here, and this is like the over-engineered part, maybe, just a little bit. So the idea there is, okay, we have the microphone, right? The microphone takes in audio all the time. There is a Python thread. It's just like different threads, right? Because you have to wait, like the CPU has to basically wait for the microphone to give anything back. So you can use a thread because yeah, it doesn't have to be a process. So you use a recorded thread, and that just basically cuts up the continuous stream of data into chunks of like a half a second that we trained on, right? And then pushes to a queue. That queue is then taken out of by a detection thread, and the detection thread basically calculates the MFCC features, like the smart things that they used, and then just runs the model on this. And basically the detection thread spits out either 1 or 0, it's a bell or it's not a bell. That's the idea. The 1 and 0s, it puts it in another queue, and this other queue is then read by either a notification thread that is actually using pushover to send, like you can just send an HTTP request to pushover, and that will send you a notification on your phone. So that's quite nice. And I also actually, at home, I have like an ESP32 to my LED strips at the back of my desk, so they start flashing when like the bell is pressed. People have noticed on video calls, but yeah. Who cares, right? And then there's also a save thread, and here comes the really interesting part. There's a save thread which basically says for every time the model said this was a bell, right? We're gonna save this to a folder called unlabeled data. And the idea there is that from the beginning it's gonna be shit, and over time you want it to train to get better and better and better and have less and less false positives. And in the beginning it was actually pretty shit, so the whole system did work. The idea is there that I have unlabeled data now, so that's just pieces of half-second audio. You put them on a front end, and you just say, here, there's all, you can just like listen to them and then say this is correct or this is wrong. That's all you need to do. Then you click save, and it gets put into labeled data. Now the machine knows like what is a bell and what is not a bell. And you have this on top of all of the data that you already had to train the model to begin with, right? But now you're basically mining for data that is specifically difficult for the model. Now, label data. Now you have that. Another button on the front end is just basically to say, I think that right now I have enough data to retrain, to retrain the model to make it better. So you click it, it sends to a retraining API. The retraining API is basically an asynchronous job queue, so it immediately sends like an ID back. The ID can be used by the front end to basically keep track of like how far it is in the retraining schedule. And then the retraining job starts. And the retraining job is basically just what I built in the beginning to train the model at the first time. And it kind of just gets all of this newly labeled data, already has the data that I had, smooshes it together, and then creates a new model, right? And then it kind of looks like the new data. Like, does it better than the old model on the new data? That's obviously you want to check that. But if it does, it's going to send that to model storage, which is the newest, latest, best model, right? And you get like you have an update ready thing. And so at that point, the detection thread basically every so often it checks, like, is there a new model in the model server storage? If so, yes, then just pull it in and start working with that. So it just kind of does this on the fly, which is really, really nice. So now I have actually a closed loop in which every single time it annoys me and it bugs me, I can just say no, 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 and then it just takes that into account and makes itself a little better every time. It actually works to a point, like it has like the elbow curve thing going on. So at some point you need like a lot of different examples again to make it even slightly better, but that's to be expected, that's machine learning for you. But this is actually the thing that is running right now. So I have a little bit more time. So the idea here is that this whole system is all like Dockerized and very nice and like in Docker Compose or whatever. So the idea is that I cannot, or I don't necessarily have to keep running this on the Raspberry Pi. I could do it also on my laptop and do it like on a live unprepared demo thing. So I might actually try and do that as well. I did test it this morning, but so please bear with me if it doesn't work. The demo gods are not with me today. So let me just get out of here real quick. All right, so what you can see here is like I have the dashboard thing. Let me just make this a little bit bigger. So if you look at what is in the folder, right? So there is the dashboard thing, there is, which is like all of the stuff that you need for the dashboard and the relabeling stuff, right? It's made in Plotly Dash if you're interested, it's kind of nice. Then there is, of course, data, which holds the old data, the unlabeled data, and then the newly labeled data. The Docker Compose YAML, obviously, to set everything up. The models bucket is basically just where you dump all the models. And there is this nice thing that I just basically, when a new model comes in and it's better, you just put it in the folder, symlink to it as latest.model, and then it just always tries to pull the latest. And then the model server, which is the next one, just will kind of compare hash functions, or like hashes, to just see if the model is still the same or not. And in that way, it will figure it out. So the model server then actually runs the model, is with sklearn, which is not the deep learning TensorFlow stuff, which you don't want. It's all very, very slow. In this case, it's super simple, just that. And then retraining is the whole like job queue API thing that you saw in red a little while ago. So if the gods are with me, you can see that if I do Docker Compose PS, there's basically nothing running, right? As of this moment. And then if I do Docker Compose up, I'm not going to build this. I'm not stupid. Right? Then it kind of just sets up everything, and boom. Everything should be running right now. If I now do the Docker Compose PS again and there is an exit, I will just try and run away from here. If it's not, then it means that everything worked. All right, everything is up, which is very, very good. All right, so that means that right now the doorbell detector is running. I have smartly disabled my input. So I'm going to enable it now. I really hope that there's not false positives right now. That would be pretty shitty. I'm going to set up my phone to be loud. And then I have like a nice example of my bell. It's going to be pretty loud, so I'm sorry for that. But my bell is also very, very loud. So, and now it should. It gives me the notification. So we can actually, thank you. So we can actually go in there and, what was it again? The model server, right? So the model server actually has like the bell detected stuff here. So it's now just logging, and now I should be able to say, there we go. It comes in, and now it comes back. So in this way, it just kind of keeps running and like does all the stuff. Actually, this morning I basically figured out that I have all the Docker containers still like on Raspberry Pi stuff. So that was a bit of a mess. But like the whole thing works now, right? So that's really nice. It's somewhat maintainable. So in that sense, it's also like a success in that case. And then what is obviously still required to show is the relabeling dashboard. Don't expect too much of this. This is not like impressive. So this is the idea, right? So you just review the doorbells. You have the different MP3s, right? So if I now, this is what I had this morning. I didn't disable my input. So when I basically played what I just heard, then you just keep being in a loop, right? So I just have to disable it for a while. But so this is basically like the half-second windows that it recorded, right? So in this case, I can just say like, this is correct, this is correct, this is correct. This was my, yeah, so this is wrong. It just got my voice as well, right? It might be that, no, it's actually, no, it's not, no redeeming qualities here. But this still has like some bell in it, right? So this is correct. Then you can kind of save the labels, nothing to review. And then if you trigger the training, it says training successfully started, and then hopefully, yeah, so now it starts actually like sending the stuff back. So now a background process has been started. The whole thing is being retrained. So you will also see right here that it's basically, yeah, letting my laptop shit the bed right now. But yeah, you have, everything is running, right? So it's now calculating the MFCC features. However, I didn't implement this very well. So it does this, like it calculates the MFCC features for everything again, which is, yeah, a little bit of waiting. But hopefully that will come through a little bit longer, like little bit later. And then basically it just goes kind of through all the steps, fills in the model if it's better. And actually I can allow you to watch that as well. If I do the logs to the retraining worker. Yeah, so this is basically all of the stuff that the cross-validation was doing. So the grid search CV that I told you to do, basically testing a whole bunch of things. And then here you have the AUC. So it's the area under curve. It's basically how well is the model kind of doing. And then here is like the best solution that it found, with old AUC being 95, new AUC being 94. So it's not going to be slipping in the new model because it's just worse in a sense. But you can see here it actually becomes very interesting. This actually should all be in a dashboard, but I'm a bit lazy, so now it's in the terminal, right? But this is the idea. Like if you ever worked with machine learning, it's what is called a confusion matrix. And it's basically on the bottom, you have like bell, no bell, actual. So this is like actual bells and not actual bells. And then this is basically predicted bells and not bells. And in this way, you can basically figure out, okay, like it had 580 bells correct, but it missed like one, right? And then that's really good. That's what you want to have. I optimize for as much as possible not missing a bell, because I can always relabel like false positives, but like if I miss a bell, I would never know, right? So that's like the trade-off you have to make. And then there is like 40 false positives, where here there was 2. So it's actually quite a bit better. Like the new, but then like for some reason it says that the AUC is worse. I actually don't really know. But yeah, so now the job is okay. So if you then go back, it basically says nothing because I'm my own user and I don't need confirmation, goddammit. But that's basically it. So now if anything else comes up, it also just adds back to the list. And yeah, I have had my Pi run this for so long actually right now that the storage became full because of all the false positives. We all know this, right? But I would consider that as a success in some sense because it's been online long enough. All right, so thanks for sitting through this. Any questions?
Why are you not using the cloud? I mean, you're over-engineering things.
It's a good question. I would say that already right now, like going through the cloud with pushover, right? So if I send, no, but I mean, if I send to pushover, like with the HTTP API, it takes like a little while to come back. And my ethic is quite high, so I have to basically like scream all the way down already. And like if you also have to send like all of the audio bits to the cloud as well, and then get it back, it's probably gonna be a little bit too late. But it's a good question. But it is like with deep learning, I would have considered it. But with this, it's just gonna run on a single Pi. Don't really see a reason to use the cloud. But for the training, maybe that could be interesting. Anything more?
Are you hoping for a Nobel Prize?
Ooh, ooh, that's beautiful. That's beautiful. I think on this bombshell we should probably end this. Oh, that's amazing. Oh. No, okay. So if there's no more questions, I will be here around, so you can always ask questions as well. So I hope you found it interesting, and thanks for joining. Yes.
I'm here writing for Hackdead. Do you have a write-up of this online anyway?
No, but there are 2 YouTube videos that I made about this. They're not about exactly the same. They're like more high level, but I can send them to you if you want. And I could write this down as well.
Yeah, if anything you have, genialist@hackaday.com.
All right, awesome. But I'll ask you.
Do you have a dog, and how much does he hate you right now?
I don't have a dog, which is amazing in this case, because actually what was interesting, I don't think if I can, if maybe I can find it.
Just buying a dog would probably help.
That's actually, yeah.
That's biohacking.
That's biohacking, indeed. But I wonder what the most like effort is, like going to the store and get dog treats or like keeping this alive. It's a bit of a trade-off, right? If I go here, one of the wait.
With the dog, you might get a lot of false positives anyway.
Yeah, that's the thing I was worried about. But if I go to like the wrongly, so if I label it as ambient, it basically means that it's just normal sound, right? But it was labeled as a bell, and I hope. Yeah, this. You know what this is? This is us, like my girlfriend and I, in the kitchen, like eating our cereal and banging with the spoon against the thing. And that was like the hardest thing to get out, like to not have like as a false positive. And then you're also eating and you feel like your cell phone is like constantly buzzing. And you're like, I'm not gonna say this because she's gonna hate me for it, and I don't want this. So yeah, that was like the most difficult false positive to get rid of, basically. Yes.
How long did it take you from start to because I see November.
Yeah. Well, I've been at this for a while, but it's been intermittent, right? So like also all of these things are just continuous because I label them through the dashboard. But I would say probably like 40, 50 hours in like man time, something like that would be probably close. But it's like more, it's not necessarily like the diving deep because you can make a lot of stuff really fast. It's more like, oh, it's broken again, fuck. Or like for some reason, like I also found this that for some reason the thread sometimes stops and then like the whole Docker container doesn't crash, so it doesn't restart itself. So you just stop getting bells at some point. But that means like the moment that you know that you're stopping getting bells, it means that you missed one, which is really annoying. So yeah, it's been off and on for like a while.
You could make a system to check if the Docker is running properly.
Make it bring the doorbell.
That's something. Like have it flash like another color for like debug me, please. That could be something.
You know, we used to have this radio program with Geluid by Q-Music.
Mm-hmm.
Is machine learning going to make the quiz redundant?
Ooh, good question. No, I don't actually think so. Because like I'm portraying it here as like really nice and everything, but it takes a long time and like a lot of finicking to actually get something good out of it. And it's just like, is it a bell or not a bell, right? It's super simple. So I don't think so. And also like through the research that I've been doing for this thing, I found that like audio classification is not like the hottest topic right now. So it's not like, for example, with computer vision, Google like outputs all of these models that already are trained on like tons and tons of data. So you can basically retrain it with just a little bit of data of your own because it already kind of knows how to see in some way. You don't have those kind of models for audio yet. So it makes it a lot more difficult to like get a substantial enough amount of data to be able to train something like het geluid, I would think. It might work, but
quite niche because like I know there are some applications that you can run on your phone and then it just listens to the birds making sounds and then it's able to guesstimate which kind of birds is.
Yeah, for birds and environmental sounds, it's actually used a lot indeed. And actually, if you look at I think it's called BirdNet. Yeah, so if you run it on BirdNet, you actually get like the spectrogram going on. So that's actually almost exactly the same. And they will probably use exactly the same method as this because there isn't that much going on anyway. So it's just like taking the spectrogram and like doing some kind of machine learning on it. But they do have like a substantial amount of data.
Damn birds that mimic your doorbell.
and then some kind of lights start flashing, and then yeah.
Is their data open? Because then just download all their samples and train your program with BirdSound just to know, because BirdSound might like.
Well, maybe actually. That's actually a really interesting idea. There goes my other weekends. No, that's actually a really good idea. Yeah.
Would it be extensible in a way that, for example, it learns your girlfriend's and your voice and just opens the door automatically if it recognizes one of those two?
Actually, it might. I think voice recognition is something else. A little bit more difficult.
Even if you say have like the secret words.
Yeah, like the hot word detection, right? Yeah, it's kind of the same idea. And actually, this system is like generic enough that it might just work. I just think you need like a seed data set to just get like a model, and then once it starts outputting stuff, you can like use a retraining loop to make it better and better. It could be possible, actually. Yes. I think also the Google Homes or whatnot, like the spying devices, basically, they use on device this kind of model first, and then they basically just create a model that only detects OK Google. That's the idea. And then, yeah, sorry. Or like Alexa or whatever, right? And then so it basically detects only that, and then it starts sending its buffer through the cloud for like the rest of the NLP, basically.
Lots less data, so
Yeah,
you
yeah.
don't want too much data from individual devices.
Mm-hmm.
Yes.
Yes.
Have you considered using multiple microphones and do some kind of beamforming so that it just detects it in the direction of your doorbell and not all the...
It's too easy.
No, actually, seriously, that would truly deserve like the stamp of over-engineered, I would guess. But I don't know how. So have I considered it? No, because I really don't know how. But it could be cool.
Contact microphones.
Yes.
Right, all this AI stuff, it's proper cool and all that.
Yeah.
Would you like to learn how to open a doorbell without danger of death?
Yeah, maybe yes. Yeah, I mean, I'm fine with wiring, but it was also just like a bit of the laziness of just. It's actually also quite nice, right? You have like this package that you don't have to like install, and but indeed, like it was also a bit like you have the normal wiring of like Arduino, and then you have like the 240 volts wiring, and you're like, I'm not sure. So yeah.
It's easy.
All right, awesome. But I'm always willing to learn, so yeah. All right. Thanks again for all the attention. And, welke sticker was het?
The traffic, the reverse, the proxy and the load balancer.
Yes. Maar ik moet eerlijk zeggen, ik heb daar zo wat random shit op geplakt. Want ik heb zo'n keer voor 1 euro... Ja, voor 1 euro heb ik zo'n keer een setje gekregen. En, maar ik heb nog niet met traffic... meestal Nginx, maar